So in this video, we're trying to compare a few differential equations and see which one basically recognize the method that we want to use. Um, I like to start with checking if. So checking first linear. Then if the linear doesn't work, I'm going to write it as y prime. These are all first order for the first order linear equations, for first order ODEs. Then I write it as a function of t and y, and then I try to write it as a function of t uh, only and a function of y only as a product of the two. And then that gives me separable. Um, and then if all of these fail, of course, there are other methods. We can write it as m dx plus n dy equal to 0 and look at the derivative of m with respect to y and derivative of n with respect to x. And if this is equal, means exact. So looking at these, first of all, here I can see that in the first equation, I can see that there's e to the power xy and cosine of y. This is definitely not linear. Here I can see that there's a term that only has y, a term that doesn't have y or y prime, and a term that only has y prime. This is linear. Um, Moving on, here again, a term that doesn't have y or y prime, a term that only has y, and a term that only has y prime. Again, linear. So these two are linear, and then I move on to this one, a term that only has y and the term has only y prime, but also you can see that it's y prime equal to a function of y only times function of x only. Maybe simplest y possible one. So it's both linear and exact. So in general, I think this is a bit easier if you do linear, and this is the easiest one in terms of separable if you want to solve. Uh, Not the easiest one, but it's one of the easy ones. And so basically, I still prefer linear over separable for this one. But again, it's one of those that you can choose, pick and choose. Um, Going back all of these, they're only linear basically because there are the coefficient of y is non-constant. So let's start with this one. What are the steps that I want to take? The first step always is to put in standard format after recognition. And standard format, there is a t coefficient of y prime. You want it to disappear and become 1, so you divide. And so I get y prime, divide that by t. I get t, if I divide this by t, by t, by t, what I'm ending with is 1 plus 2 over t, y equal to e to the t over t. And here, this is p of t, and this is g of t. The second step is to compute mu. Mu is equal to e to the power p of t dt, and that is e to the power integral 1 plus 2 over t dt, which is e to the power t plus 2. I want to write ln of absolute value of t, but also t is bigger than 0, so absolute value goes away. But let's clean this up. Do not keep it in this format. So I can, because there is a plus in the exponent, I can write it as e to the t times e to the power 2 ln of, I'm going to get rid of t in absolute value. And then if you remember, e to the power ab is equal to e to the power a to power b. So I'm going to use that. It's going to be e to the power ln of t to power 2. And this is e and ln are inverse of each other. So I will get e to the t times t squared. Now that we did this part, the last part is to basically find the solution. You can check that basically this has become y times that mu that you have, derivative of that. And then you can solve for y, which is the formula is 1 over mu integral mu times g of t, mu of t also, right, plus c. So what do I end up in here is y is equal to reciprocal of this is e to the power minus t, t to the power minus 2, integral, again, I will have e to the power minus t, t squared, and g of t is also e to the t times divided by t, right? And so now plus c. Now let's clean it up. E to the power minus t, t to the power minus 2, integral of e to the power minus t and e to the t are simplifying each other out. Oh, times integral mu is t squared e to the t, and g of t is e to the t divided by t dt plus c. And from here, I can see it's going to be e to the power minus t, t to the power minus 2, integral t, put the two e's together, e to the 2t dt plus c. Notice that exponential multiplies by the independent variable. This is integration by parts. How do I do that? The vanishing one is t. The one that I want to integrate is dv equal to e to the 2t dt. Then du is dt, and v is going to be e to the 2t divided by 2. Now, these two multiply, and integral of these two. So you end up with don't forget 1 over mu. Don't forget plus c. What else do you have? You have t e to the power 2t divided by 2, then minus integral of the bottom row, which is e to the 2t divided by 2 dt. So this is e to the power minus t, t to the power minus 2, and t e to the power 2t divided by 2, integral of that is e to the power 2t divided by 4 plus c. You can put this through, and then what you end up with is for the first term, one of the t's go away, and e to the power 2t and e to the power negative t is e to the t over 2t minus, then you will have these two, which is going to be, again, e to the t over 4t squared. And then you will have plus c e to the power minus t divided by t squared. Okay, so it's somewhat neat, and then you can plug in the initial value. So when I'm plugging in the initial value, it's going to be 1 and 1. So that is 1. So this is step 4, IVP, and I'm trying to compute C. So 1 is equal to E over 2 minus E uh, divided by 4 plus C e to the power negative 1 over 1, so I can ignore the over. And so I can compute C e to the power minus 1 is equal to 1 minus E2 plus E over 4. Put these two together. 1/4 of E minus half of a E is just minus 1/4 of a E. And then, so what is remaining is to actually replace C in there, and that's Y equal to e to the t divided by 2t minus e to the t divided by 4t squared plus, and e minus e squared divided by 4 times e to the power minus t divided by t squared. And that is your final answer. Okay, so now back to problem 1, or A. Um, we decided this is not linear, this is not separable. I tried, you can write it as dy dx. And see that things are not going to separate, basically. Dy dx is going to be equal to negative y e to the power xy plus e to the power x divided by x e to the power xy plus cosine of y. You can see that there's no way of factoring and separating. So I'm going to suspect exact equation. And remember, what multiplies x is m, what multiplies y is n, and that's the one. Remember, m comes before n in alphabet, x comes before y. And so the whole story is with exact equations, I am looking for a potential function of x and y such that m such that phi sub x is equal to m and phi sub y is equal to n. So I can use compatibility condition, which is telling me, so if I have already taken partial respect to x, let's take the partial with respect to y. So that would be partial of m with respect to y, and then I compare it to partial of n with respect to x. So basically, to check if the condition is met. And here, if I take the partial, so I'm still in step 1, recognition. Partial of m with respect to y is going to be equal to, here I have a product rule. So first it's going to be e to the power xy, then it's y times e to the power xy times the derivative of the exponent in terms of y, which is x. And then derivative of e to the x with respect to y is 0. Then I have to find partial of n with respect to x, which is, in this case, again, a product rule, and I get e to the power xy. Similarly, x e to the power xy, e to the power xy. And then derivative of cosine of x is going to be just 0 because it's a constant in this case. So what happened is that these two equal, so exact. Now the next step is to basically solve exact. Solving exact involves a couple of things. First, you want to find a phi in terms of a phi such that basically partial of phi with respect to x is m. It could be from either side. So first thing that I do is I try to find phi by integrating m in terms of x. And so that is integral y e to the power xy plus e to the x dx. And that gives me, so in the first one, y is a coefficient of x and coefficient of e to the x. So it's a constant. And so what I get is y e to the power xy divided by y. And the derivative of e to the x is just e to the x. The constant that we typically put in, we have to remember, because we take the antiderivative with respect to x, the constant could be a function of y. And that's what we do. So now that we did this, how do I find the function of y that I should have integrated? That's my next question. And so in that situation, I have to basically figure out a comparison with n because that's a phi of y. So what do? Step 3, I take the derivative of the phi that I found with respect to y, and then I compare to n. And that is, take the derivative of this. Oh, by the way, this is just going to be e to the power xy plus e to the x plus h of y. And the derivative of that with respect to y is going to be x e to the power xy plus e to the x goes away, h prime of y. And n was x e to the power xy plus cosine of y. So h prime of y is going to be equal to cosine of y. For h of y is going to be sine of y. 5 phi, go back where you computed the phi and replace h of y there. Maybe even put the box around this so you know. So phi of x and y is equal to e to the power xy plus e to the power x plus sine of y. Remember, we're not looking for phi, we're looking for a y or a solution. And a solution is a level curve of this potential function. And so solution is level curve, which means you set this equal to a constant. And that is, and so this is the general solution. It's not explicit, but that's fine. What I need to do is to use the initial point. So x equal to 0, y equal to pi half, and let's plug it in. You get e to the 0 plus e to the 0 plus sine of pi half, which is equal to c. C is going to be equal to 3. The initial value solution is e to the power xy plus e to the power x plus sine of y equal to these add up to 3. And that's your answer.